List of alternative nonmetal classes. In chemistry, after nonmetallic elements such as silicon, chlorine, and helium are classed as either metalloids, halogens, or noble gases, the remaining unclassified elements are hydrogen, carbon, nitrogen, oxygen, phosphorus, sulfur, and selenium. The nonmetallic elements are sometimes instead divided into 2 to 6 or 7 alternative classes or sets according to, for example, electronegativity, the relative homogeneity of the halogens, molecular structure, the peculiar nature of hydrogen, the corrosive nature of oxygen and the halogens, their respective groups, and variations. Classification science classes provided an economy of description and are beneficial to structuring knowledge and understanding of science. The distinction between classes is not absolute. Boundary overlaps can occur as outlying elements in each class show or begin to show less distinct, hybrid-like, or atypical properties. As expressed by Nelson, care needs to be taken to remember that this classification scheme is only an approximation and can only be used as a rough guide to the properties of the elements. Provided that this is done, however, it constitutes a very useful classification, and although purists often despise it because of its approximate nature, the fact is that practicing chemists may. 2 classes. Rudicia. The nonmetals are simply classified according to their inclination to form chemical compounds. The halogens are not distinguished. 3 classes. Wolfsburg. The nonmetals are divided based on a loose correlation between electronegativity and oxidizing power. Very electronegative nonmetals have electronegativity values over 2.8. Electronegative nonmetals have values of 1.9. Gargaud et al. The halogens are in a class of their own. A statine is classified as a nonmetal, and the remaining nonmetals are referred to as other nonmetals. If selenium is counted as a metalloid rather than another nonmetal, the resulting set of less active nonmetals hydrogen, carbon, nitrogen, phosphorus, oxygen, sulfur are sometimes instead referred as organogens, Chomps elements, or biogens. Collectively, these 6 nonmetals comprise the bulk of life on Earth. A rough estimate of the composition of the biosphere is c. 1458, 3000, 1450, and 15 Ponson. Vettelheim et al. The nonmetals are distinguished based on the molecular structures of their most thermodynamically stable forms in ambient conditions. Polyatomic nonmetals form structures or molecules in which each atom has 2 or 3 nearest neighbors: carbon, CX, phosphorus, sulfur, Sate, selenium, sex. Diatomic nonmetals form molecules in which each atom has 1 nearest neighbor: hydrogen, H2, nitrogen, and 2, oxygen, Otwo, fluorine, F2, chlorine. This gradual reduction in the number of nearest neighbors corresponds approximately to a reduction in metallic character. A similar progression is seen among the metals. Metallic bonding tends to involve close-packed centrosymmetric structures with a high number of nearest neighbors. Post-transition metals and metalloids, sandwiched between the true metals and the nonmetals, tend to have more complex structures with an intermediate number of nearest neighbors. 4 classes. Field and gray. Hydrogen is placed by itself on account of it being so different from all other elements. The remaining nonmetals are divided into nonmetals, halogens, and noble gases, with the unnamed class being distinguished by including nonmetals with relatively strong interatomic bonding, and the metalloids being effectively treated as a third superclass alongside metals and nonmetals. Dinwiddle. A variant of field and gray in which carbon, nitrogen, oxygen, phosphorus, sulfur, and selenium are classified as carbon and other nonmetals. Vernon. The nonmetals are divided into 4 classes that complement a 4-fold division of the metals, with the noble metals treated as a subset of the transition metals. The metalloids are treated as chemically weak nonmetals, in a manner analogous to their chemically weak frontier metal counterparts. 5 classes. Dubosquere. Noble gases were not known in 1844, when this classification arrangement was published. Hydrogen, carbon, nitrogen, and oxygen were grouped together on account of their occurrence in living things. Phosphorus, sulfur, and selenium were characterized as being solid, volatile at an average temperature between 100 degrees and red heat, and combustible and flammable. Myers et al. Metalloids are labeled as semiconductors and carbon, nitrogen, oxygen, phosphorus, sulfur, selenium as other nonmetals. Dingle. Hydrogen is again placed by itself on account of its uniqueness. The remaining nonmetals are divided into metalloids, nonmetals, referred to as quintessential nonmetals, halogens, and noble gases. Since the metalloids above the post-transition or poor metals, they might be renamed as poor nonmetals. 6 or 7 classes. Generic. After the relevant nonmetals are classified as either noble gases or halogens, the remainder are considered on a group-by-group basis. This results in 6 or 7 sets of nonmetals, depending on the treatment of boron, which in some cases is regarded as a metalloid. The size of the group 14 set and the sets of nonmetal pnictogens, chalcogens, and halogens will vary depending on how silicon, germanium, arsenic, antimony, selenium, tellurium, and astatine are treated. In some cases, the two nonmetals carbon, nitrogen, and oxygen and other nonmetals are considered sufficiently different from their heavier congeners to warrant separate treatments.